In this lesson, we're going to learn how to multiply radicals. Now, if we take a look at this question, it says solve root 8 times root 3. And we see that root 8 and root 3 are both entire radicals. And to solve this, the first thing we're going to do is we're going to remember the fact that we can actually write root 8 times root 3 as the root of 8 times 3. That is, we can place both values that are already under radical signs under a common radical sign. Well, 8 times 3 we know is 24. And so we might want to stop right there. We might want to say, well, you know what? Root 8 times root 3 is root 24. But we're not going to stop there, because here's what you're going to do. You're going to take a look at that entire radical, root 24, and you're going to suggest that, well, we might be able to express root 24 in a simpler form. And so let's go hunting for some factors of 24. So the factors of 24 are 1 and 24. We know they are 2 and 12, 3 and 8, and 4 and 6. Once we've identified all the factors, we go through and we hunt for some perfect squares. There is a perfect square, and that's it. So the fact that we were able to find a perfect square means that we can use this pair of values to replace the 24. And why would we do that? Well, because root 24, and notice that I'm going to write the perfect square, the 4, first. So 24 is the same as 4 times 6, which is the same as root 4 times root 6, and we know that root 4 is 2. Root 6 can't do any better than root 6. It is not a perfect square, so we can't remove it out of the radical sign. So there we go. So if we had stopped at 24, we wouldn't have expressed our final answer in a simplest form. So just as we reduce our fractions before we write them as our final answer, we also reduce our radical terms into a mixed radical in lowest terms before we leave them. Okay, let's go ahead and try another one, see if we can do this one. So let's say we were asked to solve negative 7 root 15 times 2 root 3. Okay, well, we know that we have sort of two portions here. We have the negative 7 outside the radical, and we have a 2 outside the radical. So what I'm going to do is I'm going to say negative 7 and 2 are both outside the radical sign, so I'm going to put them beside each other so that we can multiply them together. Then we've got the root 15 inside the radical sign, and we have a root 3 inside the radical sign. So I'm going to place those beside each other, all because it's multiplication. Now, let's go ahead and multiply these. So negative 7 times 2 is negative 14. And I can place both of these terms under a common radical sign. So 15 times 3. Okay, well, that's going to turn out to be negative 14, and 15 times 3 is 45. So we may want to stop there and say, well, we're all done. But I'm going to suggest that you don't. You take a moment to look at this 45 and ask yourself, what are the factors of 45? Well, the factors of 45 are 1 times 45, 2, no, 3, yep, 3 times 15, 4 doesn't go in, 5 does go in, and it's 5 times 9, 6 doesn't, and 7 and 8 don't. So there's all the factors. Quickly scan through looking for perfect squares. Found a perfect square. Once you find a perfect square, that is the pair that we're going to use to replace the 45 with. And we're going to make sure we write the perfect square in front. So this can be expressed as negative 14 times the root of 9 times 5. Again, negative 14 root 9 times the root of 5. I know that the root of 9 can be solved. It's a perfect square, so that's 3. Root of 5 is not a perfect square. We'll leave that in the radical sign. And then our last step is to take negative 14, multiply it by 3, and we end up with negative 42. And then the root 5 stays underneath the radical sign. So if we had been asked to solve negative 7 times root 15 times 2 root 3, do not stop at the negative 14 root 45 step. Look at the radical, make sure that you cannot reduce it. If you can reduce it, go ahead and continue and write it in the simplest form that you can find, which in this case would be negative 42 root 5.